Okay, so wieder herzlich willkommen von hier beginne ich auf Englisch. So in these tutoriums, we are going to be using Rhino 8 because that's what was suggested for Kadun geometry in the beginning, but the same rules apply for Rhino 7, Rhino 6 more or less as well. We are not going to be working on Rhino directly much, but we are going to be focusing on Grasshopper. In the meantime, if you have any questions, you can ask directly. You don't have to wait for a certain time. So how I run Grasshopper first is when I open Rhino, first of all, it's going to be installed. After Rhino 5, Grasshopper always come installed as part of Rhino. And Rhino 8 has optional Grasshopper 2 installer if you prefer to install it, but it's by default it's not installed, which I also don't suggest because it's still in work in progress. So to open it, I can either type in Grasshopper to Rhino, like any tool, or I can just click here on this launch Grasshopper button. And it opens Grasshopper, can that what we call as a canvas that I see, and the ribbon. Many of you, I think, know about this kind of basics from the math plugins and the tutoriums that Martin Rice made. And you might notice that I have some extra tabs here, like human UI, and Lunchbox. These are plugins. So in this section, at least, we are not going to be covering them. I'm just going to be talking about some basics. So to start, what is Grasshopper and why it's important for us to learn as, let's say, architects? The main idea behind Grasshopper is sort of a visual coding environment. What does it mean? Like in coding, where you type in some word or some commands to make things do something, here in Grasshopper, you can also do the same. Only difference is it's much more convenient because we are using tools. For example, instead of using a layer of code, you can just here select, for example, addition, which lets you put A and B as numbers, and then you get a result. So you can even use this as a calculator. And of course, there are more advanced stuff that comes, and as well as you can manipulate lists and information, text, data from any kind of source or mathematics, and you can use that information for your progress. This, of course, includes geometries, which is very important in the architecture field, which you can get like 2D geometries like circles, lines, rectangles, polygons, or you can also get surfaces, like freeform surfaces. You can extrude them, you can make 3D elements from this. And you always have to remember that this is more or less always mathematical. So what is the difference between working in Grasshopper and in Rhino? Let's see the difference. So for example, I'm going to place a point in Rhino. Now, when I select this, I can check here the information on this object, in its properties, blah, blah. This part where what I have in Rhino for now doesn't interest me. The thing is, this is an object now in Rhino. I can manipulate that by giving some commands. I can move that point somewhere and so on and so forth. This can be a line, this can be a curve, this can be a 3D object. But for Grasshopper objects, I can double click on my canvas. I can say a point, for example. Well, point is not a great example. Now let's say rectangle, which I want something that's actually controllable. Let's say 10 for the size of it. And then you get one object, which is not selectable in Rhino. Technically, this object exists only virtually. I mean, Rhino stuff are also virtual, but this one doesn't have any object in Rhino yet. I can right click on it and I can say bake, select the layer and click OK. The baking process means that I am writing it inside Rhino now. So when I select it now, I can select the object. In this case, I can still manipulate like any kind of Rhino object. So is this part clear? What's the main difference between saving something in Grasshopper and having something directly in Rhino? All right, thanks. Now, to explain further, what can we achieve in Grasshopper that can be helpful for us? So to give some examples at first, I can say, for example, biophysics calculations. Let's say you have a building modeled in Rhino or in another program which you can get simple geometry to Rhino. And in Grasshopper, you can, for example, calculate the area of the glass. You can then get some values and then you can use those values to calculate biophysics stuff. Or you can, for example, make site studies because Grasshopper have some extra tools called like Ladybug, which gets weather data, sun data, and you can use that data actually to see how is the position of your building, where is the sun coming, where is the wind coming, and you can analyze those. Another option would be Rhino is quite flexible when it comes to dealing with organic objects. And let's say normally you are working with ArchiCAD or Revit, but you have to design a very organic form, a very organic facade. In this case, you want to use Rhino and Grasshopper to achieve that because it's much easier. And you can here then divide it the way you want. You can arrange its positions. Maybe you can make some custom panels. And it's therefore it's important right now in Cadon geometry is a good tool to use or at least have because you can at least use it at certain point with this complex organic forms that we have in Cadon geometry. To start with that, let me explain a little bit the interface. As you can see, it's a separate part from Rhino and it has its own ribbon. I think you have it until here by display, the tools, and the rest is plugins. On the top part, you have the main menu stuff that's quite boring, nothing we are actually using much. Maybe later on you can use it to manually edit your environment a little bit. What I suggest though, I want draw icons not clicked. I want draw fancy wires and I want draw full names. What does it change? Let me show you. So if I have rectangle, it says here rectangle, I see the full name of the parameters, the inputs and outputs. And then if I draw full names, if I deactivate draw full names, I would only see the letters representing those parameters. If you're experienced enough or prefer that way, you can use this. This is much more compact. But if you don't know what that tool specifically wants, it's kind of more difficult to understand what's going on. So that's why I like to keep them actually always on. Another thing is the icons, because I want to know what tool this is directly. If I select icons, sometimes these icons are quite understandable, but in some cases they are quite not giving the clue that you might need. And another thing is to draw fancy wires. We are going to see that later on today when we are connecting some stuff. So what is the main principle? The things that we select here from the ribbon, either the tools like these, inputs, for example, or maths, sets, whatever we get, we have at least one of these, either an input or an output or both. In many cases, we have both. In some cases, for example, inputs, we have, for example, like a Boolean toggle, then it has only output. It doesn't have any inputs because itself is actually an input. But in these cases, on the left part, always on the left part, I have my inputs, and on the right part, I always have my outputs. To give a basic example, let's go with maths again. That's the easiest. I type, oh, by the way, I double click on canvas when I want to search something. With double click, it opens up the search part, which here I can start typing anything I want. Let's say I want a number slider. I type in number and it gives me a couple of options that includes number inside. But I don't see it. Let's say I see it now, but let's say I don't. And I can keep writing for better search. And when I see that, I can select it and it puts it here. Now, with this way, I get the default version of it. Let's say there are some shortcuts. What happens, for example, I double click and type in, for example, 10. It automatically goes for number slider because it knows a number is going to be part of a slider. If I don't want to have just a number, I can start adding stuff which actually excludes the number property for now. Now, what happens if I type in 10? The difference. On this number slider, I have values from 0 until 1. And in between, it's divided in 3 decimals. On this side, when I wrote 10, I have now from 0 to 10, and it's divided into 10 pieces, and I have only full numbers. Now, can I edit those? Like in many tools that you can do, you can either double click and get a menu like this. You can right click and you can see if there is edit options. In this case, I want to go for edit, for example. And here I see the name of the slider, which is what's written on this side. I can change it. Let's say NS for number slider. Then the grip style you can change here. For me, shape and text is okay. And then here for the rounding, I can define how many decimals it is. 2, 1, 0 doesn't matter. But instead of, for example, giving a 0, I can also set an integer instead of floating point numbers. An integer doesn't have digits, so I only have normal natural values. Now, the minimum value, I want to keep it 0, for example, and maximum value, I want to get 10. I say, okay. So this way, I actually change this to the exact same thing that this does. And do you see how many extra steps I had to take while I could just type in 10? Now, let's say, though, I want minimum of 5 and maximum of 15. Now, what would I do in this case? I have 5 and I have 15, and I don't want to edit every time when I want to have something. Let's say I want to have a value between 0 to 360, and I can type in 0 smaller than 360, which gives me from 0 to 360. The number sliders would understand almost all values that you put in. So I can even give, for example, 0, let's say 180.500 is smaller than 360. So what I write is, okay, I want 3 digits after the point, and I want it to be minimum 180.500. Well, actually, let's make it 0, 0, 0. And then it's smaller than 360. So 360 is my limit. I say enter. And as you see, I start from 180 and I go up till 360.000. In this case, I am also getting what's in the middle. So these shortcuts you learn in time, but it's quite useful to know the shortcuts. Um, let's continue with these two now. By the way, there is any question up until here? No, great. So I want to use the inputs and outputs, right? Now I have my value here, 15, and I put this by clicking this semicircle here, which is the output, and I am putting this to input A. And the same thing I do here, and I take this and I put it to B. So what am I doing is 15 plus 9. And when I come over the result, hover over the result, I see one locally defined value, 24. So it worked. But what am I going to do with this result? Well, if you just want to display it, I double click and I write here panel. Alternatively, instead of using a panel, this is a panel where we can read data. I can also put a quotation mark, only one, enter, or I can write double slash. They are all doing the same thing. I often use double slash. You can use quotation mark, it's faster sometimes, however you want. So in this case, let's delete these. I have a panel and I have my result, and I see that directly here. Now when I change the values here, I see that the result is changing. So we can say that I have a calculator that only makes addition. Now, what we see here is A and B are inputs and result is output. But do we have to, for example, put a number slider to make this work? Instead, I can also use a different method. I can again create a panel and then I can type it in here 10. So just 10. Then I can put this to A instead of the number slider. Now what happens is one of my values is now a fixed value that I wrote in myself. This is not a number slider, so it can also mean that it's anything. So let's try, for example, something like this. Now enter, just click. Now it didn't work. What is the reason behind it? The thing is, this technically gives us a value, but it doesn't give a value to Grasshopper because Grasshopper might read this as 25.100.231. You have to define what it is. Let's try, for example, putting a number tool, which gives me that, okay, this is not a number. Let's try to put comma instead. Now it works, but does it work the way we want it? As you know, 25,100,231 plus 5 is not 5. So it's technically still not working. Therefore, we shouldn't be putting any signs in between values if you want to use it mathematically in this case. So if your input is giving kind of an error, always think about what kind of data am I putting and is it correct? Because if it's not the number that I want, then my script will not work. Let's keep this here and let's put 100 here. So I think there is not much complex about inputs and outputs. They are quite simple. And like I said, at certain points, I have pure inputs like this one that I can connect here, which would act like 0 and 1 with this case because Booleans are true or false. And in computer language, this is 0 and 1. And yeah, we can try different inputs as well if you like. Now, as you see, this panel is not just input, but it's also an output, which means I can keep putting that as an input. Now, since there are no questions on this part with inputs and outputs, I want to explain a little bit data types. What kind of data do we have? Under params, you have, for example, geometry. And this geometry gives you certain geometrical information. In this case, for example, a point or a vector or a box. As you see, these objects don't have any kind of specific parameter for input or output, which means this object is only containing something. So it contains a point, it contains a vector, it contains a box. How we can do that? Let's make this smaller. Let's say I have a point in Rhino, and I want to use this drawn point that I already have in Rhino in Grasshopper and make some things with it. So I right click on my point node here and I say set one point. Now this worked automatically because I already selected the point, but if I haven't, when I say set one point, it opens up Rhino and it asks me to point object to reference. Then I can select this and it reads that. Now as you see, when I click on it, this point highlights as green. When I deselect it, it's red. You can also see it here on the right view, or you can see it here on the top view. Now, I have my point, but what's the point of having it right now here? Now, I can manipulate this point now. What can I do? I can move it. So I want to move it. So what I can do is double click and search for a command that would actually move it. Good thing with Grasshopper is you just don't get the names, but you also get some icons, some symbols. So it's a little bit explanatory when what you want to do. So move seems like a point, arrow to somewhere, point. So which means, okay, I take it from somewhere and leave it to somewhere. So I add this point in my input part because I want to define what am I moving. In this case, it's the point. Now, the point, as you can see, didn't move in top view, but when I look from the side, it actually moved in Z-axis. It's going up. If we see it in 3D, it's like this. Now, why? When I hover over my motion part, which as you can see, when I hover over, next to the motion, there is a symbol. And that symbol, I know from geometry, is a vector, which means the motion input requires a vector data. So in this case, for the motion, it's given a point, which is clearly a vector because it's giving me direction 0, 0, 10. So it's move it 10 on z-axis. So a point can be a vector as well. In this case, let's see what options we have. I can say unit. This is the what we called for vectors. This is what we use for vectors. And then when I type in unit, I have three options here that I like to use right now. One of them is X, one of them is Z, one of them is Y. And in this case, I want to continue with the Z axis. And here I say, okay, this is 0, 0, 1. Without me giving any factor, without giving me any strength, the force to this vector is just one unit. Now, I'm putting this to motion. And as you see, my point just moved only one step, not 10. Now, I want to move it further. So in this case, let's type in here 15. There's another trick with the number sliders that I'm going to explain soon. that when I put this to factor, as you see, it moved 15 units. So now I can make it higher. Let's see here. I can make it lower. I can even make it 0. It means it stays at the same place. Now, I want you to look carefully to this though. I have my new point up here, but I didn't actually move this point to somewhere. This point is still standing here. This is an important part about Grasshopper. Any changes, any modifications you make is something new, some new geometry. It doesn't override the previous step. So we had a point here, great. And now we use the move tool. It just creates a new point that's moved. It doesn't move the actual point. It's a very important point to keep in mind, actually. So to continue, sorry, to continue, what happens if I used another kind of vector? So instead of z, I want to move it by x. So it goes in this direction. I can change the value. And as you see, this, let's use z again. This is again another point, which means I can again use a point. When I join this, it becomes a new point. Now I want to move that also. I am repeating this step. And I want to move it also in the x-axis. Now I created one more. Now let's say I also want to do the same thing again. I can copy paste these. Now I want to show you something here. When I use the point to connect it, I actually don't need this. I just want to show it because you should know that what it is. You can directly connect geometry output to geometry input, which would create this another point. Now, this time I don't want to go in that direction. I want to go in the Z direction, which is here now. But I want to make is, for example, rectangle. So I don't want to go up, but instead I want to go downside. So I need to go minus. So in this case, to change the direction of this vector, mathematically, I need to make it negative vector. So I double click what I want to do. I want to make it negative. So I type in negative. That's it. I have the negative tool. I put my unit here and I put my result here. In this case, it's going down. Now, let's say you don't want to have a huge tool in the middle of your script that just to navigate, it's just to make this negative. Let's forget this now. I right click on the motion and then here under expression, I can type here minus x. I don't give a value here because I don't want any specific value. If I put here -1, which would overwrite my input and just make it -1. But I want to make it minus x. So whatever comes, make it negative. And this works the same way. And it's much cleaner. So that's actually a very good trick to keep in mind. Now I have my 4 points. What can I do with those? Well, there are different options. For example, I can use interpolate, which is a way of creating closed curves, and start putting my points. My first point, the vertices. Of course, when there's only one point, it says I cannot create this. There is no possible way. Now I add the second point. Now here is important. I take my input before I connect it, because if I connect now, it's going to override. It's going to delete the previous connection. I want to first have my first point. Now the second point, before I connect it, I am pressing Shift or Umschalt in my key on my keyboard. And then I place it back here. Now, as you see, the error is gone because now we are creating a line. Now, my third point, this one, let's actually get rid of this point here and just put this there. Now, my third point, again, I'm taking it, I'm pressing shift and I'm putting it there. Now, this is not going to be a rectangle, obviously, but we are going to come to there. Now, I have put my third one also. Now it's time for the fourth. And I'm putting my fourth point, and now I have a shape like this, which I can use for many things. I can use, for example, as a handrail by sweeping it on a curve and blah, blah. But in our case, we want a simple rectangle. So what do I do? First of all, the degree is important. This is a curved degree. In this case, 3 makes it this curved edge, but I can put here 1, which makes it quite edgy. You can also make this 2, which is a slightly less bent curve. You can go for 3, which didn't change. And then you can go for 6, for example, that stretches out. Let's go with 1. That's what we want. Another thing is how it's going to be left out. So it's either going to be like this, 3 lines, or we want to make it actually a rectangle. So right-click and periodic, I have false and true booleans. If I put it to boolean true or false, these true false conditions we call booleans. So this boolean I put the true, and this became an actual rectangle. Now I have my curves. So if I say curve and put this here, this becomes a curve. And if I put a panel here, I can see the total length of this curve. And when I put the domain here, I know I have curves from 0 to 4, whatever. The domain here doesn't give me any information that I want. What I would need actually is the curve part. Now, can someone now give, for example, a task? What should we do with the rectangle? Any input, anything. What should we do?
Make a box.
Sure, good idea. So to make a box, what do we need first? We have only a frame. What
Yeah,
do boxes have?
the
Sorry?
same geometry on the on a different side.
Sure. Then we can move it, right? We have a rectangle, we can move it to a certain distance, and we have the duplicate of it. I go for move, curve, and I want to move it in the epsilon direction, so y direction. And I put this to motion. And the value I want to give is the value that we used for moving, so 79, I guess. Yes. So now I have 2 of them. 1, 2. Now, what can I do is when I have 2 shapes, I think use sweep tool, not sweep actually. This is not the usual way that I actually do boxes. Let's say, sorry, loft. Loft is the correct command for that when you have multiple curves and you want to kind of join them in a 3D form. So when I press Control Alt and Loft, in this case, or any tool, it shows me where it is in the ribbon. That's an amazing function that only this software has, as far as I know. So Steuerung Alt and click, or Control Alt click. Now, what Loft does is first I put my first curve here, and then I put my second curve with Shift pressed. Then it creates it. But do we notice something missing here? from a box?
Yeah, two surfaces are this.
Yep. The reason for that is actually we connected these two frames, but if they would be surfaces, we would be combining surfaces with each other. But we can continue from here as well. That's the good part of Grasshopper. You are free to do whatever you want if you're reaching the same result. Actually, the easiest way you solve this is always the best one. It doesn't make sense if you go with a complicated method because at the end, what you reach is the same thing. So I'm going to use something called cap holes. It's here, cap holes, cap all planar holes in a B-rep. In this case, I have my loft and I put this to B-rep and this becomes now a closed object. Now, do you see this flickering? One of them is green and I see some red flickerings. Does anybody know why it's like that? Can anyone tell me?
It's like there are two boxes in one. Huh?
Yes, because in Grasshopper, everything we do is still active. So when I'm not selecting anything, I only see red, which is then fine because I don't see any flickering because everything is same color. But when I click things, I can see that they highlight in green the frame, the second frame, the lofted part, which makes that flickering for us now, and the full object. What I can do is select everything and with Control, Steuerung, hold it, I can select the one that I want to exclude. And I can right click somewhere and say preview off, which then get rid of all the visible stuff that I had and hides them. And now I'm only seeing my box. Now, as you can see, we have made quite a script for just one box. And like I said, this is a good practice. So if it's good for practicing to get these kind of scripts to make something new, always remember with basic shapes, basic forms, you have direct tools, which for example, box. When I write box, I get box from 2 points, for example. I can select this. Let's say point A is my first point on this corner. And then point B, that's going to be challenge now. Let's turn this off and show it here, my points. Now, I actually need 1 point on the other corner. So actually it's this one, but moved on the the y-axis. So for that, I can simply change this one, the third one, to epsilon. And yeah, I don't need this minus x right now. So which makes me get the point here. So in original, I also don't need this or this. I could just type in and I have this. And then I can use this one, the third point, as my point B, which creates the same box. Closed, no need to use cap holes, no need to use loft, and all the others. Now, even let's make it simpler. Let's delete everything. Let's delete this point. I want 1 point. In this case, my point is 79. Let's make the same one. 0, 0. Or 0, 71, 79, 79. Let's use something simpler. 50, 50, 0. Now, I just wrote 50, comma 50, comma 0. If I would write 50 again, that would be in the z-axis. So I'm creating a point by giving its coordinates x, y, z. Now, The second point I want to have on the other side, other corner. First of all, I know that's plus 50, 50. So 100, comma, 100, comma, and it's going to be high as 50. So 50. The second point is here. Now I have 2 points. I can name them right clicking 1 and 2. And then now I can use box 2 points. I can put 1, I can put 2, and finished. I don't need all the other stuff because my goal right now is just to make a box at certain coordinates. Now, if I want to change the coordinates of these, I can type in, I can manage the point collection here. I can add more, exclude, and whatever. You can add item. You can change the values here, or you can change the values by clicking here. Let's say 100, 100, 100. Okay. Of course, our thing just became a line now. And then here again, I can set it to 200, 200, which is not going to be a box now, I guess. Okay. No, it's still a box. It's always 100. Now, is this clear how this works with this simplification of what you have and how you change it?
Yes.
Thank you, Chiara.
Mhm. Thank you.
Um, now, um, let's come to a little bit of understanding what we can realistically do. Of course, we are not going to be making boxes. Let's say I want to create some grid lines. So for example, I can put point, in this case, let's say 0 0.0, 0.0, which is my starting point. And then I want to make a line between 2 points. So let's say I want 500, 0, 0. So in this case, I want to create a line. Then I have a couple of options. I have a line, which if I see this black, I know this is just the object and not to create something. That means I don't need one. Or I can select this line, create a line between 2 points, or I can select create a line segment defined by start point, tangent, and length. In this case, what I need is the second one, create a line between 2 points. I put the start point, I put the end point, and it becomes a line. Now this line, I want to have as a grid. I say move, and attach to geometry, and move it by unit y. Now the thing is, let me give here a value. Let's say 100. Now I have one right now, right? Okay, I moved it, but I need more grids. I need maybe 10. What can I do? What I need is something called a series. I need a series of numbers. Where is this? It's under set and sequence. So I go to set, sequence, then I have here series. This like move with a unit and a series is a quite common tool set that you almost always use while dealing with buildings. Now, I get rid of the number slider for now. Now, I want to get some series of numbers, which is every 300 centimeters, I want to have one grid line. In this case, I am saying 300 is what I want as a distance, and I want 10. Now, what are the inputs? I have start, which is locally 0 at the beginning if I don't put anything else, which is fine for me. And then I have step. So step is what is the distance between my grids? In this case, I put 300. And then for the bottom, the count is how many do I want these steps, which in my case, I want 10. And let's see what I got. I'm creating a panel and reading the value. I have 0, 300, 600, 900, and it goes like this. Now, what were we doing when we were putting into input? We were always putting 1. So I had, for example, 100, and I was putting one value here, and it was moving it once. Now, if I put now this 10 values, it moves it 10 times. The good thing is, do you remember that we were using start as 0? Now let's count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 is the one at the beginning. So we are actually not excluding this one this time, but we are having it also with. Now the rest I can turn off the preview, and I have only these. Now the length of my lines are quite short compared to what I have. So let's give here in my point, instead of 500, 3000. This looks better. I mean, my Rhino file is right now in centimeters. Therefore, what I put in Grasshopper as unit is 300 centimeters. If you are working in meters, then 300 would mean 300 meters. So Grasshopper doesn't have any units. So it actually overrides what you have in Rhino. If you have 3 meters or 3 units as the length, when you put here 300, it's going to be 100 times, even if it's centimeters, millimeters, or meters, doesn't matter. So I have them now, that looks good. And I want also on the opposite direction. What I can do is I can completely create a new line, and I can create a new series, which requires almost the same amount of steps. Or I can rotate it. I can put my geometry here. Now, when I rotate it, it's not exactly where I want to. Let's check the angle. It's 0.5 times pi, which is not the way I want to read it. I right click on it and I say degrees. That turns it into actually degrees. And let's say 90 degrees. Yeah. As you see, 90 degrees is not doing me just because it needs to be on top of each other. What do we need here? Why is it not giving me the result I want to? What do you think can be the problem?
The drehpunkt, like the point on which it rotates.
Yes, exactly. And for me, that is, as an input, is plain. I have it right now, word xy, which is my 0, 0, 0 origin point, which is this point exactly. Now, where do I want to take it? I want to take it in the middle of my whole object. In this case, let's say area. Area is a way to get center points. And I can put the geometry here. Then it gives me an error. Now, of course, because this requires a area to actually calculate, so it says there is no area. In this case, that's kind of sucks, but we still have a solution for that. We can still use mid, which gives me the curve middle, and then it gives me all the middles that I have. But let's say this is also not what I want exactly. Now, I want to create a bounding box, which is this. And I want to put my content in it. And then, because this now makes a box, I think it should work. If not, we can go something else. Yeah, this didn't give me the result that I wanted. In this case, I can keep experimenting. For example, to get the middle of it, I can pick one of the lines. Oops. List item. When I look at my output here on the panel, I have my lines. It's from index 0 until index 9. The list inputs I'm going to explain further, not today, in the next tutorial, but the inputs I have here from 0 to 9, 10 inputs, and I want to select the one in the middle. Now, in this case, yeah, it's clear it's 4 and 5 are my middle ones. So I can get either 4 or 5, or I don't know, I can add one more for the convenience sake. Or let's say make it 9. So I make it 9. So we have now 9 values, which is 4 is the exact middle, which means when I put my list, this is the exact list, and index I need to put in. Right now the index is 0, and therefore I am picking the one at the top. I want to pick index 4, then that means I have to type in 4. You can also use a number slider. You can right click and give an integer like this. I'm just going to create a panel and put 4 here. Now I have the middle one, and I want to get the midpoint, curve middle, and then I want to use it as my plane. Now as you see, now it makes a perfect grid. Now, any questions from here? We did a little bit extra solutions. No questions, good. The thing is, like I said, the good thing with Grasshopper is sometimes the solution is much simpler, sometimes it takes more time. It's up to your knowledge of tools, what exists there, or your analytical thinking. What I did right now here is quite primitive. So we went with the most obvious solution in this one. You could also rotate it 90 degrees by origin and move it in the x-axis. That could also work. But let's say we solved it like this. Now, let me turn off everything and turn on only my grid. Now, let's say I want to find intersecting points. What I can do is I can go for int. Let's make it full. It's intersect. Then here I can check what I have. I don't know. I have curve and line intersections. I have B-rep line. I have line, which sounds like what I need. And put it here. Now, when I put it here, I see that I need a line 1 and line 2, which not exactly what I want. Let's see what else I have. B-rep to plane and blah, 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 blah. It's not here what I want. Let's go to physical. Now I have curve. Again, you need to put curve A, curve B. It requires some things. And it goes on like this. Now, in my case, obviously, I'm not going to get each curve. I'm going to get them as a set. So my first curve is going to be actually curves, which is this 9 values, and the other curves, which are these. Now, let's get rid of this line, and I put the curve A as my geometry, and I put curve B. Here, there is a good point. Now, of course, when we get those, we get only the points that they are intersecting with the required index. Now, here is important. Let me explain it clearly. When I put my list here, what I have here, indexes, this called a tree. And 0, 0 here is a branch, and the rest of it are indexes. And I have indexes from 0 to 8. Now, let's see what I have on the other side. Is again the same. I have a tree with 8 objects, 9 objects actually. Right now, what this tool does is, okay, what is the intersection point between 0 index and 0 index? Between 1 index and 1 index. 2, 2. So it looks for the same ones, but I want to take them each as individuals because I want to get also 0 for 1, 0 for 2, 0 for 3, 0 for 4, and goes on for everything. Now here comes in a quite nice tool called graft. I want to graft one of these. Now it gave me what I want. And let me explain what it is now. It's more important to understand how it works than the result. Now, instead of right-clicking and grafting this, I could just use graft tree. And let's join this here. And let's see what we get here now. Do you remember I said 0, 0 was a branch? Now, let's say this is my tree and I only had one branch, which has 8, 9 indexes. Let's think it more realistically like a tree. If this is a branch, I have 8, 9 leaves. In this case, I am dividing into 9 branches with 1 leaf each. I hope this part is clear. So when I join this here, instead of this, I'm getting this separated list. Now, what it does is when I join them, each curve, each branch is getting the equal value of the other branch, which is for one value, you are getting 9 values in return. When I join this now, the grafted tree, which it makes, what it makes is take 0 and give it to 0, 1, 2, 3, 4, 5, 6, 7, 8, and guess the second 0, give it to all, takes the third, give it to all, which at the end gives me all these points. Now, any question from tree and branch and index values? This is a very crucial topic in Grasshopper because once you understand this and how to manipulate this, you are much safer. Now, as you remember in the beginning, I said we have draw fancy wires selected. The reason for that was when I deactivate it, I see all my lines as this black straight lines. And if I select here draw fancy wires, you see here I have a double line, here I have a singular line, here I have a dashed line. Now the two lines, so the double line means I have a straight up list. So it's one branch and all indexes. This is called a flattened list. To show an example, let's flatten a tree. So this is the flattened version, this is the grafted version. Now, this is the symbol of a flattened tree with multiple indexes, not one, but multiple. And this is a grafted tree with multiple indexes. On the other hand, the straight line means I have only one value and not multiple values. In this case, I have only one midpoint or only one 90-degree angle. Now, let's go further with what we want to achieve. I have my points, and I want to take this grid and create a shape here. Let's play around a little bit. I am using again the list item component, list item. Now, when I put my points, let's create this. panel, put the points here, and see, I get all my points in a grafted tree. That's important actually. Let me show why. When I put this to list, and let's say I want to pick one of these points, what index should I write? Can anyone tell me?
Yeah, the coordinates of the point.
Well, that's not an index, that's the value. Okay. Now, the thing is, index, as I mentioned earlier as well, is what I have here at the beginning of my list. 0, 1, 2, 3, which is which element this is. So I have my value and I have my index. So my index, for example, for this line is 3. Now, if we look here, I have only zeros because instead of indexes, I have branches because this is a grafted tree. So how am I going to turn this into a different kind of tree that has indexes instead of branches? Anyone? I need to flatten it. Now, as you remember, when we flatten this list, we are getting straight up numbers. That's why we flatten or graft something. Now, here I can see the indexes. Here I can use the indexes. Now, since it's connected, I need to use this flattened tree. Now, instead of connecting this tree to list, I'm just going to right click and flatten this. Now, when I select it, let's actually show without the flatten. When I select, it was selecting everything because the default index was 0 and all my items were 0. Now, when I flatten this, I only get 0, which is this point. Now, of course, it's difficult to select points from here, and I have to know which index it is. What I use mostly is a number slider, which has 81 values. So I start from 0 and I go until 81. The reason is when I come hover over it, I say 81 locally defined values. Now, here, when I put my slider to index, this is the 0, then I can go for 1, 2, 3, 4, 5, 6, and it goes on like this, as you see. And after 81, like the 81 actually, the last one, is the first one. In this case, I can even put 80 here, which gives me exactly the list of full. So the 80 is the last one. Now, if I want to select the previous ones, for example, instead of going for 80, I just want to select the last one. Then I can also type in, sorry, not like this, but -1 smaller than 0. Now I have -1. I put it here, and it automatically selects the last one. If I go for -2, I don't know if I can, no, because I have to arrange my range. So if I go for 2, that's the second one from the last. So I can either go with positive or from the negative. Now let's pick some points. Totally randomly, I'm going to pick and going to create a sort of shape. You can, by the way, make this larger, the number slider, so you can define better values. I click on my list item so I see the points. Let's say I get 50. and I copy paste the whole thing, then I get 46. So I have some distance in between two. Then let's pick another one. For example, here. And one more just to create a four corner object. So let's see our points. Let's close everything else. Turn preview off. I have 4 points within my grid. What was I doing? I was interpolating. Now I can put the vertices. This was the third one. It's important in which order they are, because if I put this one first, that's going to be an S, like the letter. So let's do it like this. And what was I doing? I was doing the periodic to true, so it's closed, and I was putting the degree into 1. So it becomes like this. I mean, actually, even we can keep it at 3. Let's go crazy. So let's say I have my set of lines. So preview on. And within this grid, I have my main form. Now I can go for tool called boundary surfaces. It's something I like to use. This boundary surfaces is actually used to create surface from closed curves. So I attach my curve to edges. Becomes like this. Now I can go for extrude. Simple commands. Extrude. I put the base. This is the base. So that's my surface. And I put a direction, which is Z, like this. And then here I can give 3000, let's say. Maybe 3000 is too much. Let's go less. Now, let's say this is 1 floor high building. How can I make this 4 floor high with the same method? What do you suggest? Any suggestions? We did something similar at the beginning.
Like negative, but for x, like for x factor.
If I make a negative or like in x, I would be, let's actually do it better. We are using now extrusion. So if I actually put another unit, it becomes like this. So this is not the solution that we are looking for. It's something we did with the grids. We need to be using a series. You remember I said move, unit, and series. Now, the same mentality we can do here with the extrude. Instead of then extrusion, let's say we are using move again. I put my surface. I put my motion. Of course, we are going to have to loft it later on. And then let's say the height 300 is the height, and I want a series. So let's go with step 300, and we said 4 floors. Let's go for 4. Now, which makes it kind of a building. We can at least see the floors. Now I can go for extrude, base, unit Z in negative direction. And let's say 30. Let's say this is the floor thickness. Now what happened now is I have 30 centimeters thickness floors and 4 of them. What happens now when I want to change something here, I can add more floors I can change the distance in between them. And I can actually add more move. Let's say move, and this time in unit X. Like this, and connect this to the geometry. Now, when I turn these off, I have something like this. The reason for that is I am using the same number of series in both ways. So it both goes in this direction and in this other direction. Now, here the trick is you can keep doing it, but of course it doesn't make sense if you always go on certain directions. Let's say you want to expand or you want to change. Now, I'm not going to go detailed in that one because that's a little bit more complicated, but just to demonstrate what you can achieve with that is by using scale. So if I put the geometry here, I'm going to need a center, so I can use area. This time I can use area because I have a closed form and it gives me the center of it, which I use this to center out. Now, of course, I want to get the same size. So let's go for 1 smaller than 2. If I put the factor here, 1 makes it the scaled is the exact same size that we had. But let's say I scale it higher. Well, let's make it Komma Stelle so it changes its size. Now what happens, now it's the interesting part, what happens if I put a series here now? The count is same and the step is 1. And I put, instead of start, by the way, instead of setting it to 0, I want to start from 1 because 0 scale means it's completely gone, which I don't want. Minimum the same size, and I want it to be expand. So I actually get here a value smaller than 0, which is smaller than 1, sorry. Let's say 0.2 something. Now I put this series into factor and it becomes like this. Because in the first step, I'm scaling it as 1. In the second step, I am scaling it 1.273. And let's give it as fixed value 0.25, 250. Yeah. Now here, then I get 1.25, then I get 1.5, then I get 1.75, and at the end, 2. And then when I give more steps, my scale factor also gets higher. I go to 225, I go to 5, whatever. And I can lower this value to actually get less change. Or I can turn it to negative. Well, in this case, not negative. Sorry. Actually, maybe we need to put it 1. Yes, because it's multiplying. To turn it around, we have to divide it. So instead of multiplying with 1.25, for example, I'm actually dividing into 125, which gives me the opposite way, which creates forms like these. Now, of course, because it's opposite, now my minimum value doesn't matter, but the more I go, the smaller it gets. Now I can get something like this, for example. And then I can also loft this to get an actual form. I know this part is a little bit extra maybe now. Don't worry about it. We are going to go detailed in manipulating form because that's kind of the point we want to reach. So anybody have questions? we covered a lot, so I understand it's right now maybe too much to process. Maybe for some of you is not enough, but like this is kind of the difficulty in Grasshopper, that the things are quite open-ended. You might be questioning right now, why are we making this funny shape, or why are we making boxes? But the mentality behind it is that these are the tools that you can do to create anything. And that's what's going to help you with your tasks. Now, if there is no questions about what we covered so far, we are finishing in like 10 minutes. In this 10 minutes, you can ask anything related to this, either how it's going to continue, or how you can, for example, implement it to your design and whatever. Or if you don't have any questions, you can leave.
Thank you. Bye.
Thank you. Bye. Yes, the rest is sleeping. All right, let's call it a day then. We see each other then next week with a little bit more challenging task. Maybe we can do together. Thank you for coming
Will
today.
you be uploading the script maybe into that?
The script?
Yeah.
Sure, I can upload the script as well.
I mean, I wrote it also in the meantime, but I missed some steps, so it would be really helpful if you also upload the script.
Of course, no problem from my side. I can upload it.
Okay, super nice. Thank you.
Thank you. And thank you all for coming. For today, we can stop.
Thank you.
Thank you. Bye.
Thank you. See you.